Questions 21 through 25 on the 2012 Grade 10 AMC 10A. Let points A, B, C, D, and E, F, G, H are the midpoints of the line segments BD, AB, AC, and DC respectively. What is the area of EFGH? Well, A, B, C, D, and EFGH are basically midpoints, so don't get too overwhelmed by the fact that it's triple coordinates like XYZ. You don't have to really worry about that because the essential process of creating points that are midpoints is the same. So for example, if you have E, F, G, and H, and what I'll do is I'll also do the XYZ plane. So A is the origin, so that's right here, 0, 0, 0. B is 1, 0, 0, so let's say it's about here, where this is 1, that's B. And this is, of course, the X, Y, and Z plane. C is 0, 2, 0, so 0 on the X, Y, it will be 2, so approximately 1, 2. So this is where C is. And then finally D is 3 on the Z plane, so approximately here. So this is 3, and that is where D is. So now we can just connect the dots and make this shape. But really what we're interested in is just these ones, BD. So B to D is right here. And then we're interested in AB. Well, AB is just from there to there. AC, which is, again, just on the y-axis. And finally DC, which is from here to here. And we need to label now the midpoints. So the first midpoint, E, is on BD, so approximately here. And then the next midpoint, F, is on AB, so that's going to be here. And then G is on AB, so that's here. And then finally, H is on DC, so somewhere here. And that is what we are interested in, that shape. So I'll draw the lines from those points like that. So I'm not 100% sure that it's a square, but it sure does look like a square. And let's label those points. E, F, G, H. Well, now we got to find the midpoints. Well, the midpoints are just like the midpoints of the standard coordinates, right? If you had the point, let's say 1, 2, and 6, 8, and I said find the midpoint, it would just be 6 plus 1 divided by 2, and 8 plus 2 divided by 2. So that's what? 7 divided by 2, 3.5, and 5. So it's the same thing with these. You just take the points and then add them and divide by 2. So to get the F, it would be A and B divided by 2. And when you do, you just get a half, 0, and 0. Yeah. And then the next one is E. I'm doing this a little out of order. E is what? The midpoint of D and B, right? So you just take those and add them and divide by 2. So it's going to be a half, 0, and 3 over 2. And then G is the midpoint of AC, right? So that means that's just going to be A plus C divided by 2. So that's just 0, 1, 0. That's pretty easy. And then H finally is the midpoint of DC. So you're going to take D and C, add them and divide by 2. And when you do, you get 0, 1, and 3 over 2. So we got the coordinates. Now we have to find the distances. The distances from F to G, for example, you just use the distance formula. So, for example, if you wanted to find the distance from 1, 2 to, say, 6, 8, you would just go 6 minus 1 squared plus 8 minus 2 squared under the square root sign. So for triple coordinates in the XYZ plane, it's the same story. So the distance from F to G would just be 1/2 minus 0 squared, and then 0 minus 1 squared, and then the 0 minus 0 squared, all under the square root sign. So this is 1 over 4 plus 1. So that looks like 5 over 4. And that's just root 5 over 2. And then, like I said, it's most likely a square. And you can verify that by finding all the sides. I obviously have to find at least one more side. So I'll find GH, or HG. And that's going to be, looks like here, just 3 over 2 minus 0 squared. All in the square root sign, because the 1 minus 1 cancels, 0 minus 0 cancels. So this is just 3 over 2. So that means this side is 3 over 2, and this side is root 5 over 2. And it is a square. I mean, I have already figured out that this side was also root 5 over 2. Actually, not a square. Why do I keep saying square? A rectangle. Boy. Well, it's definitely a shape that has at least two sides that are the same. And therefore, 3 over 2 and root 5 over 2 are the sides. And when you find the area, that's just going to be length times width. So it's root 5 over 2 times 3 over 2. And that is 3 root 5 over 4. 3 root 5 over 4. And therefore, the answer is C. And it is a rectangle, EFGH. The sum of the first m positive odd integers is 212 more than the sum of the first n positive even integers. What is the sum of all possible values of n? Well, we have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just listing a few of the first few numbers. And if I want the first, say, m odd integers, right? It would basically be 1 plus 3 plus 5 plus 7 plus 9, blah, 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 all the way up until a certain number. Now that number, because there's are odd integers, it'll be 2m minus 1. So for example, 1, 2, 3, 4, 5, 6, 7. If I wanted the first 7 odd integers, it would go up, obviously, to 13, and that's why it's 2m minus 1. When m is 7, that becomes 13. Now, if you add these all up, it will always be m squared. And I'll explain why. If m, the actual number, is odd or even, is what we have to first consider. M is odd, m is even. If it's even, it basically becomes 1 plus 2m minus 1, right? I'm grouping the first one and the last one. Plus 3 plus 2m minus 3. I'm grouping the first and the second last, and so on. And eventually all of these will be able to be grouped together. And what that leads is, because m is even, then m over 2 is the number of pairs, and each pair adds up to 2m. So if you do that, you just get m squared. So that is what happens when m is even. When m is odd, it's slightly different. It's going to be 1 plus 2m minus 1, 3 plus 2m minus 3, but then there you're going to have one guy in the middle, because m is an odd number. And the one in the middle is, interestingly, just m. So for example, if you had 1, 2, 3, 4, 5, 6, 7, if you had these guys, if you're adding them all up, right? M is 7, m is odd. So the middle one, interestingly, is the number 7, when m is 7. But now if you add these up, again, you get m minus 1 divided by 2. That's how many pairs. Each pair is equal to 2m, and then an m. And then if you multiply this out, it becomes m squared minus m plus m. And again, you get m squared. So regardless of m being odd or even, the sum of the first m odd integers is always going to be m squared. Okay, so that takes care of the first part. The second part, fortunately, is a little bit easier to explain. And that is the sum of the first n positive even integers. Well, for example, if you have 2 and 4 and 6 and 8 and 10 and 12 and so on, right? If you add up those, 2 plus 4 plus 6 plus 8 and so on, the first n even integers, well, you're going up until 2n basically. The first n even integers will go up to 2n. And therefore, this is just going to be, if you factor out a 2, 1 plus 2 plus 3 plus 4, all the way up until n. And then, as I'm sure you know, that can be added with that famous formula n plus 1 all over, n times n plus 1 over 2. And then that just becomes n times n plus 1. So our job is to now compare this to this. And the question has told me in a very elegant way that m squared is equal to n times n plus 1 plus 212. So that is what this question basically boils down to. So my task is to find the value of n. And they're saying that we have to add up all the possible values of n. So obviously, I'm assuming there's more than one value. Maybe there's 2, maybe there's 3, who knows. So how do I do that? Well, n is what I'm interested in. Find n. So I can put everything on one side and treat this like a quadratic. N squared plus n plus 212 minus m squared. So that means n is equal to minus b plus or minus the square root of b squared minus 4a and c. And my c is 212 minus m squared all over 2a. So this is n is equal to minus 1 plus or minus 1. And this looks like it will be minus 488 and then plus 4m squared. So that's just going to be minus 487. So instead of writing it all out again, I'll just write it. And minus 487 like that. And of course, that's all under the square root sign. And that's all over 2. All right, so that's pretty decent. So now I just have to figure out 4m squared minus 487. This is what I have to be concerned with. I have to find what m could possibly be. 4m squared minus 487. Remember, n, they have told us, are integers. And that's pretty obvious since it talks about the first n positive even integers, right? You can't have 6.2 positive even integers. N obviously has to be an integer. And the only way it can is if this is an integer, if you take the square root of that. So that means this has to be some perfect square. And this, by the way, is called a discriminant. Discriminant. So the discriminant has to be a perfect square. That's the only way when you take the square of it, it'll be an integer. So our task has now boiled down to 4m squared minus 487 is equal to p squared. Okay? Sorry, this should be an 847. I accidentally reversed the digits. 847. All right, no problem. Okay, so now we're going to do this 4m squared. Let's put this p squared on this side and put the 847 on that side. Now 4m squared minus p squared is 847. That can be factored. So we got 2m, p, and p, and minus and plus, and that equals 847. And I believe 847 we can factor 7 times 11 times 11. Okay, so this is something we can work with here. 2m minus p and 2m plus p, those have to equal some combination of 7, 11, and 11. But obviously 2m plus p is greater than 2m minus p. Okay, the first one that I can think of is probably 847 and 1. That would probably be something that would work. And then the next one, I think, if you made 2m minus p equal to 7, and then the other one, 2m plus p, could be 11 times 11, which is 121. And then another one, 2m minus p, if you're making it 11, and then 2m plus p, 7 times 11, which is 77. I think these are the only ones that would work. Okay, solving this is pretty easy. You just add them. So 4m, the p's cancel, is equal to 848, and therefore m in this case is going to be 212. And then if you substitute back into any of these guys for p, you can solve and get 423. Very similarly, 4m here would be 128, and therefore solving m would be 32, and then p you can solve and get 57. And then for this one, 4m is going to be 88, and therefore m is 22, and solving for p you get 33. All right, I think I can do it all on one page. So now I've got the value of this. I've got a few of them actually. N is equal to 1 minus 1. I'm going to use the positive one, of course. And since this is p, it's really the square root of p squared, which eventually becomes p all over 2. So the n formula is very nicely simplified to just -1 plus p over 2. So now all I have to do is put these values of p in, and I can solve for n. So for p equals 423, n becomes 422 divided by 2, which is 211. When p is equal to 57, this becomes 56 divided by 2, which is 28. And when p is equal to 33, this becomes 32 divided by 2, which is 16. So my task was to find all values of n and add them. So 211 plus 28 plus 16 is equal to 255. And that is the answer to this question. So 255, and therefore that would mean A. Adam, Benin, Chiang, Dishan, Esther, and Fiona have internet accounts. Some, but not all of them, are internet friends with each other, and none of them has an internet friend outside the group. Each of them has the same number of internet friends. In how many different ways can this happen? So we have to first make a list of number of friends, and then for each we will figure out the number of possible cases. The choices are either 1, 2, 3, and 4. There's 6 of them, and they can have some friends, so the number of friends is not 0, but they cannot have all, so the number cannot be 5. So we're only dealing with 1, 2, 3, and 4. And the good news in this question is that 3 and 4, these are complementary with 1 and 2. And what that means is that 1 behaves like 4 and 2 behaves like 3. And the reason they're complementary is because non-friendship plays the role of friendship. So if you have 1 friend, you have 3 that are not friends. But if you have, you have 1 friend, but you have 4 that are not friends. If you have 4 friends, then you have 1 that's not a friend. You see what I mean? It's complementary. That's why the numbers are the same. So we obviously have to figure out the numbers for 1 and 2. All right, well, 1 is the easiest one. If you have a choice of, let's say I choose Adam, let's say A for Adam, he can initially choose any of the 5 remaining friends. But then the next friend, let's say Chiang, 2 are gone, right? If Adam chose Benin, 2 are gone, so Chiang can only choose between the remaining 3. So there's 3 choices. So the number of combinations is 5 times 3, which is 15. So that is how many different combinations for 1 friend, and then that would be also the same for 4 friends, because those are the same. Now we have to figure out for 2, and when we do, we can write that number in here for 3. And then in the end, of course, we're going to add them all up. For 3, there's 2 different sort of scenarios. The first scenario is when you have 2 groups of 3. So, for example, A, B, C are friends. A is friends with 2. And then D, E, F are friends. D is friends with 2. And the way to do that is, for A, from the 5 people, he will choose 2. So it's a choose notation. From 5, choose 2. And when you do that, it is 10. And then the other 3 are just together by default. Once that happens, D, E, and F are the only ones left, so they're all friends. So this is the first part. The second part is an additional way of doing it, and that is an interesting way in the sense that you put it into sort of a hexagon type pattern. And since there's 6 of them, 6 friends I should say, they go along the 6 vertices, A, B, C, D, E, F, like this. And again, you sort of group them. So let's say these are friends. A is friends with 2 people. Well, how do you do that? Similar as before, it's from 5, choose 2. But then the next 3, they have by default been isolated as friends, but there's different permutations. 3 factorial different permutations, which is 6. So this is 10, and this is 6, so you'd have to multiply 10 by 6 to get the total, and that's 60. So you have to add this 10 to this 60 to get the total, and that's 70, for a scenario where each person has 2 friends. And the scenario with each person has 3 friends, that's complementary to 2 friends, so that's also going to be 70. So the total number for this question is 15, 70, 70, and 15, which is 140 plus 30, which is 170. And therefore, number 23, the answer is B. Let A, B, and C be positive integers with A greater than B greater than C, such that A squared minus B squared minus C squared plus AB is 2011, and A squared plus 3B squared plus 3C squared minus 3AB minus 2AC minus 2BC is negative 1997. What is A? Well, we have to begin somewhere, so let's add them. I think that will help. If we do, equation 1 and equation 2 added together would become 2A squared plus 2B squared plus 2C squared minus 2AB minus 2AC minus 2BC, and then 2011 minus 1997 is 14. Now this can be grouped: A squared minus 2AB plus B squared. That's the first grouping. The next grouping would be A squared minus 2AC plus C squared. And the third grouping would be B squared plus, or rather minus 2BC plus C squared. And of course, all that is equal to 14. Now each of these factors very nicely. We have A minus B squared plus A minus C squared. And then we have B minus C squared. And that is equal to 14. Now, 3 perfect squares add up to 14. And I'm pretty sure that you can figure out that that's going to be 1, 4, and 9, right? That's the only way. But which one's 1, which one's 4, and which one's 9? Well, A is the greatest and C is the smallest. So the biggest difference has got to be 9, right? So A minus C is 9. And the other two, it doesn't really matter because we're not really sure what B is. If B is closer to A or is it closer to C? So we can just arbitrarily just give it a value. So now at this point, we know that A minus B squared is equal to 4. And that means that A minus B is equal to 2. From this next one, we get A minus C squared is equal to 9, and that means a minus c, if you take the square root of both sides, is 3. This one, b minus c squared, is equal to 1, and that means b minus c is 1. Now they're interested in a, so let's solve everything for a if we can do that. From this one, we get that a minus 2 is b, so b is a minus 2. And from this one, we get that c is equal to a minus 3. So now we've got b in terms of a, c in terms of a. We can substitute those back into here and solve. So let's do that. Let's just do it up here. I think I can squeeze it in. We're going to put those findings into that equation. So we have a squared minus b squared, which is a minus 2 from here. So I'll just immediately just do the squared part. A squared minus 4. Let me take it out of the brackets. Minus a squared minus 4, so it'll be plus 4a. And then plus 4, but it's out of the bracket, so it's minus 4. And then the c squared, in the same way, it's over here. It's a minus 3, but it's minus that, so it'll be minus a squared plus 6a, and then minus 9. And then we've got this ab, but a times b, and this is b, so it'll be a squared minus 2a. And that is equal to 2011. So let's see here. This a squared cancels with this. This a squared cancels with that. Then we have 4a, 6a, 10a minus 2a, so we got 8a. And then the numbers minus 4 minus 9 is minus 13, and then adding it to the other side, 13 plus 2011 will be 2024. And therefore this divide through by 8 this time, and when you do, you get a is equal to 253. So a really cool question, number 24. A is 253, and therefore the answer is E. Real numbers x, y, and z are chosen independently and at random from the interval 0 to n for some positive integer n. The probability that no two of x, y, and z are within 1 unit of each other is greater than a half. What is the smallest possible value of n? Well, we do not know the actual values, but we do know that they are most likely on some number line, and they are between 0 and n. And we can make x greater than y, or less than y, less than z. So I can put x here, y here, and z here. So our conditions, according to the question, are that x minus y, if you take the absolute value, the positive difference, has got to be greater than or equal to 1. That's what it means, that no two of x, y, and z are within 1 unit of each other. And then similarly, y minus z, the positive difference has got to be greater than or equal to 1, and so does x minus z. So those are our conditions. So really what we're just dealing with is, since we've set this inequality, x minus y is greater than or equal to 1, and y minus z is greater than or equal to 1. We can drop the absolute values, and then we don't need to worry about the other one, because as long as these are true, the other one will be true as well. Now the probability of that happening is greater than a half. So our task now is, how do we figure out the probability? What is the trick in this question? Well, what we have to do is we have to actually look at it from the angle of a cube and a tetrahedron within the cube. So I'll show you a diagram of what I mean. So here's a cube, and the red is basically the region that we have to consider first. And that first region is the denominator in the probability. So if the probability is considered, let's say, region 2 over region 1, this green is basically the region 1. Now, how do we figure out the area of region 1? Well, it's a tetrahedron, right? And the volume of a tetrahedron is 1/3 times the base times the height. Now, in this case, this cube is the full interval, 0 to n. So each of these sides is n. This is n, this is n, this is n. So the volume would be 1/3 times base, and the base is just this triangle. So the area of that base is pretty easy to figure out. It's just going to be 1/2 base times height. You can use this as the base, and you can use this as the height. So it's just going to be 1/2 n times n. The height of this tetrahedron is the top to bottom height right there, which is n. So this basically becomes n to the power of 3 over 6. So that is what is R1, n to the power of 3 over 6. Now we have to figure out the R2, this guy. Well, how do we do that? Well, again, we're going to use a very similar technique. We are going to use another tetrahedron. And it's this one this time. And in particular, you have to look at the black lines. Those black lines represent the region 2 that's up here. And that one is very similar in terms of its shape. It's also a tetrahedron. And that volume is calculated in a very similar way. But we have to take into consideration that it's no longer n. Top to bottom is n, right? It's the same cube. But as you can see, the lengths are shorter. And the reason it's shorter is because that is 2, that distance. So that length of the black one is n minus 2 there. And then if you notice, this length is also shorter. That's also n minus 2. And this right here is also n minus 2. And those we deduce entirely from those inequalities right there. So the volume of that tetrahedron is 1/3 times the base, which is 1/2 base times height, which is n minus 2 squared, and then the height, which is n minus 2. So this just becomes n minus 2 all cubed over 6. So that's R2, so we put this over here, n minus 2 cubed all over 6, like that. So if you were to simplify this, this basically simplifies to n minus 2 over n all cubed. And we want this to be greater than 1/2. And we have to figure out what value of n would make that expression greater than 1/2. And if you start plugging in these numbers, you'll find that the first time this expression becomes greater than 1/2 is when n is equal to 10. When it is equal to 10, it becomes 512 over 1,000. And as you can clearly see, that is greater than 1/2. And the first time that happens, the smallest value for which that happens is when n equals 10. And therefore, number 25, the answer is D.